User-level threads are like contractors hired by individual departments within the company. Each department can hire as many contractors as they need. The user-level threads are implemented by users. They are efficient and flexible. User-level threads are small and much faster than kernel-level threads, and there is no kernel involvement in synchronization for user-level threads. There are 5 advantages of user-level thread. The first one is user-level threads are easier and faster than kernel-level threads. They can also be more easily managed. The second one is user-level threads can be run on any operating system. There are no kernel mode privilege required for thread switching in user-level threads. The team can quickly decide how to allocate tasks without waiting for approval from higher management. And the last one is it can adopt the best strategy that suits their specific needs without one-size-fits-all rules.
Now I'm going to talk about the disadvantages of user-level thread. Okay, for the first one is cannot use multiprocessing, or we call limited parallelism. Since user-level threads are managed within the context of a single process, they are not well suited for applications that need to take full advantage of multiprocessing processes or for applications that require parallel execution across different processes. For the second one is blocking operation. If a user-level thread blocks due to I/O or other reasons, all threads in the same process can be blocked, leading to a poor utilization of resources. For the last one is no true parallelism. User-level threads cannot execute in true parallel on multi-core system since they are managed by a single kernel-level thread.
Kernel-level threads. Kernel-level threads are like full-time employees managed by top management. It has full access to all resources and easy communication. The management handled by the operating system kernels. More overhead due to central management. It is good for complex tasks. Kernel problems affect all KLTs. Kernel manage all thread details. KLT slower than user-level threads. There are 6 advantages of kernel-level thread. The first one is there are 6 advantages of kernel-level thread. The first one is multiple threads of the same process can be scheduled on the different processes in kernel-level threads. The second one is if a kernel-level thread is blocked, another thread of the same process can be scheduled by the kernel. The third one is potential conflicts between teams can be managed better as the higher management has visibility and control over all teams. The fourth one is the kernel routines can also be multi-threaded. The fifth one is management has complete overview and can allocate resources more effectively across the entire company. And the last one is since management controls all aspects, integrating across department can be smoother and more coordinated.
Okay, now I'm going to talk about the disadvantages of kernel-level thread. First of all is overhead. Kernel-level threads generally have higher overhead due to the involvement of the kernel in thread management, which can impact overall performance. Second one is less flexible. Kernel-level threads often have less flexibility in terms of scheduling, policies and custom thread management compared to user-level thread. Okay, for the last one is portability. Application using kernel-level threads might require modification when ported to different operating systems with varying thread management implementations.
Comparison between ULT and KLT. User-level thread and kernel-level thread differ significantly in their implementation, performance, and behavior. User-level threads are implemented by the user, usually through a user-level thread library. But kernel-level threads are managed by the operating system. Second features is context switch time. These threads are managed without kernel support, leading to lower context switch time. For KLT, the context switch time is more compared to user-level thread due to the involvement. However, user-level threads are managed by the program itself, not the operating system, because the operating system does not know about these threads. They cannot run in the true parallel on multiple processors. All the user-level threads in a one program are usually treated as one by the operating system. So, only one thread can run at a time. In contrast, kernel-level threads are managed by the operating system, which keeps track of each thread. These threads can run on multiple processors at the same time, allowing true parallel execution. The next feature is efficient implementation. User-level threads are also easier to implement compared to kernel-level threads. The implementation of kernel-level threads is more complex and requires kernel-level support. Blocking operation. A significant drawback is that if a thread performs a blocking operation, the entire process is blocked. Moreover, about the KLT, if a thread is blocked during a system call, other threads in the process can continue to execute.
It features recognize. For ULT, OS doesn't recognize it. It represented by program counters, stacks, registers, and process control blocks, PCBs. And for KLT, it is recognized by OS. It features thread management. For ULT, its library includes the source code for thread creation, data transfer, thread destruction, message passing, and thread scheduling. And for KLT, the application code on kernel-level threads does not include thread management code, and it is simply an API to the kernel mode. In future hardware support, for ULT, it doesn't need hardware support, and for KLT, context switches for KLTs requires hardware support. Next, for feature creation and management, for ULT, it may be created and managed much faster, and for KLT, it takes more time consuming to create and handle. In feature examples, for ULT, some instances of user-level threads are Java threads and POSIX threads. And for KLT, some instances of kernel-level threads are Windows and Solaris. The last feature is operating system. For ULT, any OS may support it, and for KLT, the specific OS may support it, and different OSs handle them differently.